Come to the last subtopic on this chapter, the last chapter in this course, BUM2413 Applied Statistics 6.2 Contingency Table. So 6.1 is about the goodness of fit test, 6.2 is about the contingency table. So the lesson outcome by the end of this topic, you should be able to test two variables for independent using chi-square test and also test proportion for homogeneity using chi-square test. It's actually the same procedure. The difference is the hypothesis only. Okay, if you know how to conduct the test for independence, you also know how to conduct the test for the homogeneity because the procedure is still the same, but the difference is only the hypothesis. Hypothesis independent, you want to test the independent. Hypothesis for the homogeneity, you want to test the homogeneity. Right? So when we talk about the contingency table, so what is the contingency table look like? The contingency table is called an row times column contingency table. So means that you have to know what is row, what is column. Row is baris yang menegak, the horizontal. Row, the horizontal part, and the column is the laju, the vertical one. Right? So row is the baris, column is the laju. So row is this one, column is like this. Okay, the contingency table is the row times column table. Okay, next. Okay, you will have this table. This one is the row. Okay, O. What is O? O is the observed frequency. Observed frequency O located at row 1, column 1. Row 1, column 1. So, O here is located at row 1, column 2. Right, so O here is located at row 2, column 1. Here, row 2, column 2. Okay, you have to know your position of the observed frequency. Next, N1 dot. N1 dot is total row 1. Hasil tambah row pertama. N2 dot is total row 2. Hasil tambah baris kedua. N dot 1 is total column 1. And N dot 2 is total column 2. Total frequency, okay? And N dot dot is total all. Okay, total all. Right, this is the contingency table. So the difference between contingency table and two-way ANOVA table, contingency table display frequency distribution of qualitative data because we talk about qualitative data. Two-way ANOVA, quantitative value. Okay, in contingency table represent the distribution of group in population. Okay, for two-way ANOVA, the data is intended to be used to interpret how quantitative variable impacted the factor because we talk about the factor. Okay, contingency table is about the categorical data, qualitative data. Okay, next. Okay, this is also the difference. Testing for independent between two variables. 6.2.1. Now we have come to the test. As mentioned earlier, contingency table is used to test the independent and homogeneity. So the first one, test for the independent. In order to find out whether or not the two categorical variables are associated with one another in a single population. For example, in a single population in a class, you want to know, is it the female and the male related to each other? Okay, female and male is a categorical data. Is it a gender? Gender can be categorized by female and male. Right, this female and male, is it related to each other? We can know by conduct the independent test. So the procedure for independent test still the same. Step number 1, you have to know what is your H0 and H1, what you want to test. Okay, step number 2 must be a chi-square because we still in the categorical data, we will use a chi-square test. So this is the formula to find the chi-square test. Still the same, you must have O, you must have E. O is given. E, you have to find it out. Okay, so how to find the E, we'll look at later on. Number 3, chi-square critical value. So chi-square critical value is little bit different here. The nu is equals to row minus 1 times column minus 1. Okay, that's why in contingency table, the number of row and column is very important. So please determine your row and column correctly. And then step number 4, we will reject H null if chi-square test is greater than chi-square critical value. And number 5 is draw your conclusion. Okay, it's still the same procedure. Now the difference is only the calculation and the formula. Okay, what is the hypothesis for the independent test? The hypothesis, H null, the row and column are independent from each other, or X has no relationship with Y, or female and male is not, female is not related to male. Okay, or female is independent, not related. Saling tidak berkait, H null. Okay, H null, no relationship, or independent, or not related. Maksud yang sama. Give you the same meaning. So, if H null not related, H1 related, or dependent, or has relationship. Okay, so the keyword here, H null, not relate, independent, no relationship. H1 relate, dependent, and has relationship. Okay, step number 2, calculate your chi-square test. In order for you to calculate the chi-square test, you need the E. Okay, where can we find the E? E can be found from the contingency table. Here. Okay, just now, you will be given your O. O here will be given because O is the observed frequency. First step, you need to find total row 1, total row 2, total row 3, how many rows you have. And then you need to find total column 1, total column 2, total column 3, and how many column you have. And then you need to find total all. After you get all the total, you need to find E. N I dot times N dot J, total row 1, okay, times total column 1 divided by total all. Okay, total row 1 times total column 1 divided by total all. You will get the first E. And then you follow total row 2 times column 1. And then total row 3 times column 1. Done for column 1, you move to column 2. Okay, don't worry. We will look at later on the example. Okay, example 6.5. The data below shows the number of insomnia patients according to their smoking habit in Malaysia. Okay, insomnia can be divided by 2, insomnia or not insomnia. Smoking habit is also, we have smoking and not smoking. Habit can be divided by smoking and not smoking. Okay, at alpha 0.01, can we say that insomnia is independent with smoking habit? So, independent. Is insomnia not related to smoking habit? Is insomnia no relationship with smoking habit? So, you have insomnia and you have smoking habit. Okay, insomnia can be divided by insomnia, not insomnia. Habit can be divided by smoking and not smoking. So, the first step is your H null and H1. What will be the H null and H1? H null, insomnia is independent of smoking habit, or can. Insomnia is not related to the smoking habit. Okay, so here insomnia is related to the smoking habit. Give the same meaning. Right? Step number 2, you need to find the chi-square test. This one step number 1. Step number 2, you need to find the chi-square test. In order for you to find the chi-square, you need the E. For you to find the E, you need the contingency table. So please build your contingency table. So this one is your O, 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 O. Okay, this one is your O. First step, you need to find total row 1. 20 plus 40, you will get 60. 10 plus 80, you will get 90. Total row 1, total row 2. Then, total column 1, 20 plus 1 plus 10, you will get 30. Total column 1. Total column 2, 40 plus 80, you will get 120. Okay, this one total row 1, total row 2. Total column 1, total column 2. And then, you total all. Overall total. You'll get 150. So this is your contingency table. You must have this contingency table in your answer sheet. Okay, next, after you total the row and column, we want to find the E. Okay, this one is O. O is given. Now find E. E for 20. Okay, look at here. E for this one. E for 20. Okay, E for 20 is equals to, I'll put here, E for 20 is equals to, 20 is located at row 1, column 1. So, total row 1, 60 times total column 1, 30 divided by all, 150. You will get the E for 20 here. 12. Okay, how about E for 40? 40 is located at row 1, column 2. So, E for 40 is equals to total row 1, 60 times total row 2. 120 divided by 150. You will get this one. How about E for 10? Look at here. 10 is located at row 2, column 1. So, row 2 is 19 times column 1 is 30 divided by 150. You will get E for 10 is equals to 18. How about E for 80? 80 is located at row 2, column 2. So, row 2 is 90 times column 2 is 120 divided by 150. You will get E for 80 here. Okay, after you got the E, you put into this formula. O minus E square divided by E. Okay, O for 20, here is 20 minus E, 12. You square it, divide by 12. You will get the 5.3333. And then lastly, sum it up. 5.3333 plus 1.3333 plus 3.5556 plus 0.8889. You will get 11.1111. Okay. Chi-square critical value. Chi-square alpha, row minus 1 times column minus 1. How many row we have? How many column we have? Look at here. We have 2 row, 2 column. So, 2, 2. Chi-square alpha is 0.01. Row is 2 minus 1 times column is 2 minus 1. So, you will get chi-square 0.011. 6.6349. Okay, then you compare. Chi-square test 11.1111 greater than critical value, reject H null. So, if you reject H null, what will happen? You reject this one. So, you take this. At alpha 0.01, insomnia is dependent of smoking habit or insomnia is related to the smoking habit. Okay? So you must build your contingency table. So remember, please build your contingency table. So let's look at exercise 6.2.1. Let's do one exercise for the independent. Okay, the independent test, the exercise 6.2.1, number 1. Let's discuss the solution. A study is interested to test whether there is a relationship between gender and cost at her university. So gender can be divided by women and men. So it is a categorical data. Cost can be divided by natural science, social science, and engineering. Is also a categorical data. So they want to investigate the relationship. When we talk about the relationship, it is a dependent test because this one is a qualitative data. Right. She randomly sampled some men and women on campus and asked them if their course was part of natural science, social science, or engineering. The results can be shown as follows. Right. Can we conclude that these two variables are related to each other by using alpha 0.05? So this one is an independent test. So independent test, step number 1 is your hypothesis. H null, the gender and cost are not related from each other, or we can say that independent. So the gender and cost are related to each other. This is a dependent. Okay, step number 2, we want to find the chi-square test. In order for you to find the chi-square test, you need the E. So E you can get from contingency table. So build the contingency table first. Right, so this one is the O. Okay, so build the contingency table. Submission and submission. Summation of row 1. Summation of women. 10 plus 14 plus 10. You will get 34. And then 11 plus 8 plus 4. You will get 23. Okay, then move to the column. Column 1, 10 plus 11, 21. Column 2, 14 plus 8 is 22. Column 3, 10 plus 4 is 14. And then overall total, you will get here 34 plus 23 is 57. 21 plus 22 plus 14, you also will get 57. This is the overall total. Okay, done for the contingency table. Now you want to find E. Okay, based on our contingency table, now we want to find E. Okay, so E for 10. 10 is located at column 1, row 1. So 34 and 21. So 34, sorry, here is E11 is equals to 34 times 21 divided by 57. So here you will get 12.5263. Okay, next, E for 14. 14 located at row 1, column 2. Row 1, 34 times column 2, 22 over total, 57. So you will get 13.1228. Okay, next, how about 10? 10 located at row 1, column 3. So E is equals to 34 times 14 divided by 57. You get 8.3509. Okay, move. 11. 11 located at row 2, column 1. Row 2 is 23, column 1 is 21. So E is equals to 23 times 21 divided by 57. Next, how about 8? So 8 is located at row 2, column 2. So 23 and 22. 23 times 22 divided by 57. Okay, next, E for 4. 4. 4 located at row 2, column 3. 23 and 14. So 23 times 14 divided by 57. So here you will get. Okay, done all for the E. Okay, done for the E. Now calculate this one. O minus E square divided by E. So the O is 10. 10 divided by E, 12.5263 square divided by 12.5263. So here you will get. So make sure you calculate it correctly and check with my answer if I make any mistake here. Alright, next 10 minus 'Next, and the last one here for minus. Okay, and then what you need to do is you need to sum it up to get the chi-square test. Chi-square test is equals to 0.5095 plus 0.0586 plus 0.3257 plus 0.7532 plus 0.0867 and plus 0.4814. Here you will get 2.2151. So make sure you correctly press your calculator. Okay, step number 3. Chi-square alpha, row minus 1, column minus 1. So row is equals to 2, column is equals to 3. So because we have 2 row and 3 column, right? So chi-square alpha is equals to 0. Alpha is 0.05. Row minus 1. Row is 2 minus 1 times 3 minus 1. 1 times 2. 2. So alpha 0.05. Nu is 2. You will get the chi-square. Critical value is 5.9915. So step number 4. Since chi-square test is equals to 2.2151 is less than chi-square critical value, do not reject H null. Okay, what will happen if you do not reject H null? You accept the H null. Accept the H null means that at alpha 0.05, the gender and cause are not related from each other, so they are independent. So there is no relationship between gender and cause. Okay. So now about the university here. About the what this one? A researcher wishes to see if the way people obtain information is independent of their educational background. A survey of 400 private college and university graduate using this information. At alpha 0.005 tests the claim that the way people obtain information is independent of their educational background. So you can do independent test here, H null and H1, and then please do the contingency table, and then you can try to do on your own this one. Okay, I'll give you the answer The answer for the chi-square test is equals to 21.3466. Okay, and the conclusion and the decision is reject H null. Okay, so please try to do number 2 for the independent test here. The last subtopic 6.2.2 test of homogeneity proportion. So as I mentioned, test of homogeneity the same as test of independent. The procedure is the same. The difference is about the hypothesis only. Because hypothesis independent, you want to test the relationship. In the homogeneity, we want to test the similarity. So in the test of proportion of homogeneity, we want to test the homogeneity or similarity of the population proportion pi. Okay, the homogeneity test concerns on the homogeneity or similarity of two or more subgroup of population proportion. Okay, when you have two pi population proportion, you want to compare the similarity, you can use hypothesis testing. But when you have more than 2 pi, you cannot compare using traditional hypothesis. You have to compare using contingency table for more than 2 population proportion. The procedure for testing the homogeneity of proportion is similar to the procedure used to test the independent, except for the hypothesis statement only. Okay. So these are the difference between the hypothesis and the contingency table. So what is the hypothesis for the homogeneity? So H null pi 1 equals to pi 2 up to pi k. So how many population you have? And then for H1, pi I is not equals to pi j for at least one I is not equals to j. Or you can say that H null all proportions are the same. H1 at least one proportion is different from the others. Step number 1. How about step number 2? Step number 2 chi-square test, same for independent test. Step number 3, 4 and 5 also same for independent test. So for example, a researcher selected a sample of 50 seniors from each of 3 secondary schools and asked each student, do you come to school on your own? The data are shown as follows. So, do you come to the school on your own? Yes. Do you come to the school on your own? No. Okay, there are 2 categories here, yes or no. So, you have school 1, school 2 and school 3. Okay. So, test the claim that the proportion of students who come to school on their own is the same for all schools. So, we have school 1, school 2 and school 3. Test the claim that the proportion pi for the student who came to school on their own is same for all the schools. So, this one is the homogeneity test because we talk about the similarity of proportion. So, step number 1, your hypothesis. All proportions are same, at least one proportion is different from the others. Right, so pi 1, pi 2, pi 3 because we have school 1, school 2 or school 3. Okay, first, step number 2, you need your chi-square test. In order for you to get the chi-square test, you need the E. And then, in order for you to need the E, you have to build a contingency table. So, this is your contingency table. First, sum row 1, sum up row 2. Sum up column 1, sum up column 2, sum up column 3. And then, overall. Okay, how to find E for 18? E for 18 is equals to 56 times 50 divided by 150. How do we get E for 22? E22 is equals to 56 times 50 divided by 150. Okay, and so on. You will get the E here. Okay, and then after that, you sum it up this one, you will get the chi-square test, 1.5958. So go to here, your critical value, because we have row equals to 2, column equals to 3. So row minus 1 times column minus 1, 2 minus 1 times 3 minus 1 is equals to 2. Type here. Okay, And then since chi-square test is less than chi-square critical value, accept H null. If you accept H null, what will happen? All proportion are the same at alpha 0.05. Okay, same as independent test. The difference is only